Hey guys, Mr. Boris here. I just realized that with the coronavirus, I never had time to show you this truly beautiful result. And that's that we're going to use Taylor series to show that this crazy statement, e to the pi equals -1, is true. Wild, right? This is just for fun, but let's take a look. So we all know the series for e to the x. Because, we take this class or whatever. And I'm going to write out just the first couple terms of this series because we're going to use this to kind of help provide the basis for how we're going to prove this. Okay, so a lot of kids have been wondering, why can't we just use imaginary numbers? So instead of doing e to the x, why don't we do e to the ix? So we're going to replace all the x's with an ix, so it becomes 1 plus ix plus ix squared over 2 factorial plus ix cubed over 3 factorial and so forth. Okay, now the next part of this is going to require us to remember kind of an interesting fact from Algebra 2 trig, and that's what happens with powers of I. So what I remember is I, of course, is I. If we do I squared, that's -1. That's what I means. If we do I cubed, that's I squared times I to the 1, which is -I. I to the 4th, that's I squared times I squared, so -1 times -1 is +1. Okay, and then from there it actually repeats. So when you keep going, I to the 5th is equal to I to the 4 times I, which is 1 times I, which is just I. I to the 6th is I to the 5th times that, so that's -1. So these four just repeat over and over again, kind of like the sine and cosine derivatives. All right, so keeping that in mind, let's rewrite this, and we're going to write this as e to the ix equals 1 plus ix. So I squared is -1, so that's a minus x squared over 2 factorial. I cubed is -I, so minus I x cubed over 3 factorial. I to the 4 is 1, so plus x to the 4 over 4 factorial. I to the 5th is just I, so that's plus I x to the 5th over 5 factorial. Okay, now when we wrote out imaginary numbers in Algebra 2 trig, we usually wrote them like this, like a plus bi. We separated the real part and the imaginary part. So I'm going to do that here too. So let's separate out these real parts. So I'm going to get e to the ix equals 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial, and so on. And then if I factor an I from the other terms, so I'm going to circle those really quick. If I factor an I have an x, and then minus x cubed over 3 factorial plus x to the 5th over 5 factorial. OMG, look at that. That's so incredible because you guys are recognizing that's the series for cosine and sine. So e to the ix is actually just cosine x plus I times the sine of x. This is called Euler's formula. That's the same Euler who E is named after and came up with Euler's method. So if you want to prove our basic thing that we started with, plug in x equals pi. So e to the I pi equals the cosine of pi plus I times the sine of pi. The sine of pi is 0. The cosine of pi is -1. Gorgeous. And all using Maclaurin series. How cool is that? Hope you guys enjoyed.